Welcome to the deep dive. Today, we're diving into some fresh AI research
Ooh.
straight from the Artstick Press from
Yes,
February 11th, 2025.
Okay.
It looks like AI is getting even better at understanding our world, from all sorts of unpredictable systems, even to the structure of knowledge itself.
Yeah, it's truly remarkable. We've got researchers actually proving that these classic learning algorithms, like TDO0 learning, can actually work in a complex real-world scenarios.
Wow.
Imagine an algorithm that learns from experience just like you, but it can handle the unpredictable nature of something like the stock market or even the weather. That's what TD0 is all about. And
yeah.
this breakthrough means we could get more accurate predictions in
Okay.
fields like finance and climate modeling.
So we're talking about a TD or a learning algorithm that can handle chaotic data like the stock market.
Exactly.
That's a game changer. What other advancements in training AI stood out to you?
Another standout is what they're calling simulation-free training. Imagine teaching a robot to navigate a complex obstacle course entirely in a virtual environment. You wouldn't need an expensive physical robot during the learning process.
That sounds like it would speed up the training process a lot.
Yeah, and make it more cost-effective.
That sounds like a major leap forward, especially for fields like robotics. No more robot crash test dummies.
Right.
It's not just about robots, though, is it?
No, it's not just robots. These advancements have implications for any field that's dealing with complex, ever-changing data.
So lots of different fields then.
Lots of fields. Think about deep Gaussian processes. These are like statistical models on steroids, able to predict how systems evolve over time.
Interesting.
Whether it's traffic flow or the spread of a disease, these models can predict future states with impressive accuracy.
So deep Gaussian processes can predict how things change.
Yeah.
But can we be sure about those predictions?
That's where it gets even more fascinating.
Okay.
Deep Gaussian processes can also estimate the uncertainty in their predictions.
So they know how sure they are about their own predictions.
Exactly. Imagine being able to predict not just when that traffic jam will clear, but also how sure you can be about that prediction.
That's a whole other level of insight.
It is. This is crucial for making informed decisions,
Mm-hmm.
especially in high-stakes fields like medicine.
So knowing how confident we can be in an AI's predictions is huge.
Absolutely.
Especially when it comes to things like medical diagnoses. But with AI becoming more powerful, how do we make sure it benefits everyone?
That's a critical question, and thankfully, new research is tackling AI fairness head-on. Researchers are actually quantifying bias in AI systems across social groups.
Okay.
They're using techniques like latent class analysis. Think of it as a detective tool that uncovers hidden patterns
I like
to reveal why certain groups might be unfairly targeted by an AI system.
So almost like an AI watchdog.
Yeah.
To ensure that these powerful systems are being used responsibly.
Exactly. This work is essential for building AI.
Yeah.
That's fair and equitable for all.
Now, how do we ensure that these AI agents are actually doing what we want them to do? Especially if we don't even fully understand how they learn.
It's a challenge, akin to training a dog, without knowing exactly how its brain works.
Oh, so very tricky to...
But new research on steering Markovian agents is exploring ways to guide these AI agents towards desired outcomes, even when their learning process remains somewhat of a mystery.
Okay, so how are researchers making progress in this area?
They're developing methods that incentivize AI agents to align their actions with our goals, even if we don't have a complete understanding of their internal workings.
So we're giving the AI a goal and letting it figure out
Yeah, it's about finding ways to guide them without needing to micromanage their every move.
the best way to achieve it.
Yeah.
But what about those times when AI makes a prediction with high confidence, but it turns out to be completely wrong?
Right.
How do we address that?
That's where what they're calling conformal prediction comes in. Think of it as AI providing confidence intervals on its predictions. This new method focuses specifically on those instances where the AI was super sure of itself, but ended up being completely wrong.
So it's like double checking.
Yeah, by understanding why the AI made those mistakes.
The AI's work?
We can improve the reliability of these systems, especially in critical applications, like self-driving cars.
It's not just about fixing the error. It's about understanding why the AI was so confident in the first place.
Exactly.
This could be a game changer for making AI more reliable in high-stakes situations.
Absolutely.
Now, I noticed a cluster of papers focusing on the power of context in AI. What's that all about?
One exciting breakthrough is what they're calling causal kernel clustering. Imagine an AI that can group data into meaningful clusters,
Yep.
not just based on superficial similarities, but on actual cause and effect relationships.
So the AI is understanding cause and effect.
Yeah, it's like moving from simple correlation to understanding causation.
That's a big step.
A fundamental leap in how we understand the world.
Where could this lead us?
The potential is immense, especially in fields like medicine. Imagine using this technology to understand why certain treatments work for some patients but not others.
Okay.
Moving beyond simple correlations to unraveling the complex web of cause and effect.
This is really groundbreaking stuff. It seems like this research is all about moving beyond simple pattern recognition to a deeper understanding
It is spot on.
how the world works.
This drive for deeper understanding extends to large language models as well.
Those LLMs.
LLMs, that's right. Researchers are making these incredibly powerful models, more efficient and adaptable. They're even figuring out how to train them on massive data sets with highly specific human preferences without needing to handhold them through every step.
So we're talking about LLMs that can learn from human feedback without being spoon-fed. Every detail could transform how we interact with AI daily. But with all this talk about LLMs, let's not forget about those other research areas pushing the boundaries of what these models can do. What caught your eye in that realm?
2 papers stand out: GuideLM and Provergen.
Okay.
GuideLM explores making LLMs better at guiding conversations. Imagine an AI that can interview you about your life, dig deep into your memories, and then help you turn those stories into a compelling autobiography.
So an AI that helps you write your autobiography.
It's like having an AI co-author who understands the nuances of language and can help you craft a truly engaging narrative.
The possibilities for storytelling, education, even therapy are mind-boggling.
They are.
And what about Provergen?
Provergen tackles a fundamental challenge in AI. Can we teach LLMs to reason logically, like a human expert?
Interesting.
This research introduces a data set that combines the power of LLMs with the rigor of symbolic provers.
It's combining those two approaches.
Think of it as a logic champion, going head-to-head with an LLM in a battle of wits.
Okay, so they're competing against each other.
The goal is to push the boundaries of what these models can achieve and evaluate their logical reasoning abilities.
So it's less about finding a winner and more about pushing both LLMs and symbolic provers to their limits, ultimately benefiting the entire field.
Exactly.
That's a fantastic approach.
It is, and it reflects the broader trend of creating AI that's not just powerful, but also aligned with human values and capabilities.
That's a key point. It's not just about making AI smarter. It's about making it more understandable and trustworthy.
Exactly. And this leads us to 2 remarkable foundation models, LEAD and Decipher.
Okay.
LEAD is a foundation model trained on the world's largest EEG dataset. It's designed to detect Alzheimer's disease early on.
Wow. Offering the potential for earlier intervention. And better outcomes for patients.
That's right.
That's AI being used for good, tackling one of the most challenging diseases we face.
Absolutely.
And what about Decipher?
Decipher is like an AI Sherlock Holmes for materials science. It can predict the structure of crystals simply by analyzing their diffraction patterns.
It's almost like an AI-powered microscope that can peer into the heart of materials.
This has huge implications for drug discovery, materials design, and our understanding of matter's building blocks.
Incredible. But with these massive foundation models, there's always the concern about their resource-intensive nature. Are researchers addressing that?
Absolutely. One technique called SSH slims down those massive language models without sacrificing performance.
Okay.
Imagine shrinking a giant dictionary to the size of your phone without losing any words or definitions.
So making those large language models more accessible.
Exactly. This could bring the power of AI to everyday devices, revolutionizing how we interact with technology.
That's a game changer for accessibility. Privacy, even energy efficiency.
It is.
What other strategies are researchers exploring to make AI more efficient?
There's exciting research on what they're calling adaptively pre-trained encoders. Pre-training gives AI a head start, but figuring out the best strategy can be tricky. This framework learns to adapt its pre-training on the fly, making it much faster at learning new tasks.
So the AI is learning how to learn better.
It's like an AI that can learn from its own learning process, becoming increasingly efficient at mastering new skills.
Amazing. And this adaptability is essential as AI continues to evolve and expand into new areas.
Absolutely. This brings us to a final set of papers, exploring the interplay between human perception and AI development.
Okay, I'm intrigued. Tell me more about this human-AI connection.
One paper looks at using human visual cues to improve object detection in low visibility conditions.
So, like giving AI the ability to see through fog or haze?
It's like giving AI the ability to see through fog or haze by leveraging the same strategies our brains use.
Wow. So we're teaching AI to interpret data in a way that aligns with human perception.
Exactly.
That's brilliant. Are there any other examples of this human-AI synergy?
Another paper explores fine-tuning multimodal models with what they're calling knowledge-adapted captions. It's about ensuring the captions used to train AI are both informative and relevant, preventing the AI from generating nonsensical outputs.
So making sure the AI is learning from high-quality information?
It's like teaching AI to be a more discerning reader, focusing on the most important information, and avoiding those wild tangents that can derail LLM conversations.
With the vast amount of data available, that's more important than ever.
It is, and this emphasis on quality extends to the exciting world of spiking neural networks, or SNNs.
SNNs?
Yes, these networks process information using pulses of electrical activity, just like neurons in our brains.
Fascinating.
What's even more impressive is their energy efficiency.
So instead of power-hungry GPUs, we could have AI running on devices that sip energy.
Exactly.
That's remarkable. But are these SNNs as accurate as their traditional counterparts?
That's the key question researchers are exploring, what they're calling quantized SNNs, or QSNNs, which further improve efficiency by compressing the network's components.
So even more efficient.
Even more efficient to maintain accuracy, even after compression. They've developed a new method called weight spike dual regulation, or WSDR, inspired by information theory.
Information theory, that sounds complex.
It is, but the key takeaway is that WSDR helps maintain the accuracy of QSNNs, even after they've been compressed, making them a viable alternative for resource-constrained applications.
We've covered so much ground today.
We have.
From AI learning from experience to mimicking the human brain. What's the ultimate goal of all this research?
It's about creating AI that's both powerful and beneficial, capable of solving complex problems while remaining aligned with human values.
That's a worthy goal.
Yeah.
But it's clear that the journey is just beginning. There's still so much to explore and discover in the world of AI.
Absolutely, and that's what makes this field so exciting. We're on the cusp of a new era of intelligence, one where humans and AI will collaborate to shape a better future.
Welcome back to our deep dive into the latest AI research. You wouldn't believe the amount of groundbreaking work happening every single day.
It's truly remarkable how fast this field is moving. So much to uncover. With all this progress, though, it's important to critically evaluate these advancements and understand their potential impact. Precisely. We need to look beyond just what AI can do and consider the broader implications, both positive and negative.
That's a great point. We need to be mindful of how AI is shaping our world. Speaking of shaping, one paper really stood out to me: obfuscated activations bypass LLM latent space defenses. It sounds a bit like a sci-fi thriller, to be honest.
It does have a certain ring to it. This paper dives into the ongoing struggle between those who are trying to make LLMs safer and those who are trying to exploit them for malicious purposes.
So it's like a battle between AI security researchers and hackers.
Precisely. This research demonstrates that even cutting-edge defenses designed to detect harmful activity within an LLM can be bypassed using a technique called obfuscated activation.
Obfuscated activations, that sounds sneaky.
It's essentially a way to manipulate the inner workings of an LLM so that it can execute harmful commands without setting off any alarms. Imagine disguising a computer virus as a harmless file.
Okay, now that's a bit unsettling. This research really emphasizes the need for more robust and adaptable defenses to keep up with those who might try to misuse these powerful AI tools.
Absolutely.
What other strategies are researchers exploring to address AI safety?
Researchers are constantly developing new methods to make AI more secure and reliable. One fascinating paper explores a technique called calibrated unsupervised anomaly detection in multivariate time series using reinforcement learning.
That's a mouthful. Can you unpack that for us?
Essentially, it's about training AI to identify unusual patterns in data, even when we don't have many examples of those anomalies to learn from. Imagine trying to teach a child to spot a rare bird when they've only ever seen pictures of common sparrows.
I could see how that would be a challenge. So how does this research approach the problem?
They propose using reinforcement learning, or RL, where an AI agent learns by interacting with its environment and receiving rewards for making good decisions. It's like the AI is playing a game, trying to figure out which patterns are normal. and which are unusual, and getting points for correct classifications.
So the AI is learning through trial and error, constantly refining its ability.
Exactly. And the beauty of RL to spot anomalies is that it encourages exploration. The AI isn't just limited to the patterns it's already seen. This helps prevent overfitting, where the AI becomes too specialized and misses anomalies that deviate from its limited experience.
So it's like teaching the AI to be a more curious and open-minded detective.
Precisely.
This could have huge implications for fields like cybersecurity, where detecting unusual network activity is crucial for preventing attacks.
Absolutely. Now let's shift gears for a moment and delve into a paper that takes a very different approach to AI development, one inspired by the principles of evolution.
Evolution and AI. Now that's an intriguing combination. Tell me more.
This paper, titled Using Machine Learning to Discover Parsimonious and Physically Interpretable Representations of Catchment Scale Rainfall Runoff Dynamics, explores using machine learning to discover simplified yet accurate representations of complex systems.
Simplified representations. Why is that beneficial in the context of AI?
Because these simplified representations can help us understand the underlying dynamics of these systems, leading to more insightful predictions and better decision-making. It's like finding the most elegant explanation for a complex phenomenon, capturing the essence without getting bogged down in unnecessary details.
That's a great analogy. So how does this research apply the principles of evolution to AI?
This research utilizes a computational unit called the Mass-Conserving Perceptron, or MCP. This unit is designed to mimic how physical systems conserve mass and energy. Imagine building AI models grounded in the laws of physics, making them more likely to produce accurate and interpretable results.
It's like ensuring the AI's understanding of a world aligns with the fundamental principles that govern reality.
You've hit the nail on the head.
That's fascinating.
This approach holds significant promise in fields like hydrology, where understanding water flow is crucial for managing resources and predicting floods.
So it's not just about making AI more powerful. It's about making it more aligned with how the natural world works.
You've hit the nail on the head. This trend of incorporating domain knowledge and physical constraints into AI development is gaining traction across various fields. It's about making AI not just intelligent, but also grounded in the realities of the physical world. Now let's talk about another fascinating area of research that you might find particularly interesting.
Okay, I'm all ears.
This research focuses on enhancing pre-trained decision transformers with prompt tuning bandits. It highlights the ongoing evolution of reinforcement learning techniques and how they're being applied to cutting-edge AI models.
Prompt tuning bandits, that sounds like a combination of different AI concepts. Can you break it down for us?
Sure, certainly decision transformers are a type of RL model that can learn from past experiences to make better decisions in the future.
So they're like AI agents with a memory of their past actions.
Precisely.
How does prompt tuning fit into this?
Prompt tuning allows us to adapt these models to new tasks by providing them with specific instructions or examples. It's like giving them a set of guidelines or a cheat sheet to help them quickly understand the new challenge they're facing.
So it's like giving the AI a cheat sheet for a new game.
Yep.
Helping it learn the rules more quickly.
Precisely. And the bandits part of the name refers to a class of algorithms that excel at exploring different options and finding the best one over time.
So it's like the AI is trying out different cheat sheets to see which one leads to the best performance on a particular task.
Exactly.
This clever combination allows pre-trained decision transformers to adapt to new tasks more effectively, making them more versatile and useful in a wider range of applications.
That's right.
It's like giving these AI models a toolbox of strategies to tackle new challenges.
This research seems to be pushing the boundaries of what RL can achieve.
It certainly is.
And this constant evolution of AI techniques is one of the things that makes this field so captivating. Now, there's another intriguing paper that I think you'll find quite interesting.
Okay, let's hear it.
This paper, LED, Large EEG Dataset for Alzheimer's Disease Classification, introduces a groundbreaking development in the fight against Alzheimer's disease.
Alzheimer's is such a devastating disease. Any progress in this area is incredibly welcome. Tell me more about this research.
Researchers have developed LED, a foundation model trained on the world's largest EEG dataset, specifically for Alzheimer's disease classification.
Wow, the world's largest EEG dataset for Alzheimer's. That's a game changer. What are the potential implications of this research?
This model has the potential to detect Alzheimer's disease early on, even before symptoms become apparent, Early detection is crucial because it allows for earlier intervention, which can significantly improve patient outcomes.
This research has a potential to make a real difference in the lives of people facing this devastating disease.
It does.
That's truly inspiring. What other advancements are we seeing in the application of AI to healthcare?
Another remarkable paper, Decipher, a deep learning method for crystal structure prediction from X-ray powder diffraction data, showcases the power of AI in materials science, a field that is closely intertwined with healthcare and drug discovery.
AI and crystal structure prediction. That sounds intriguing. Tell me more.
Researchers have developed Decipher, a deep learning model that can predict the structure of crystals simply by analyzing their diffraction patterns.
So it's like an AI-powered X-ray vision for crystals.
That's a great way to put it. This breakthrough has huge implications for drug discovery, materials design, and understanding the fundamental building blocks of matter.
That's incredible. By understanding the structure of crystals, we can design new drugs, develop innovative materials, and advance our understanding of the physical world.
Exactly.
This research demonstrates the power of AI to accelerate scientific discovery and innovation across various fields, including healthcare. This is just the tip of the iceberg. We've covered so much groundbreaking research today, but there's still more to explore.
You're absolutely right. Let's take a moment to recap some of the key takeaways from our deep dive so far.
Okay, let's synthesize what we've learned.
We started by discussing the remarkable progress in AI's ability to understand complex systems, from TD0, handling chaotic data, to deep Gaussian processes predicting future states with impressive accuracy. We then explored the crucial aspect of AI fairness and how researchers are developing techniques to mitigate bias and ensure AI benefits everyone.
We also delved into the challenge of steering AI agents, guiding them towards desired outcomes, even when they're learning processes.
It remains somewhat mysterious.
Conformal prediction also stood out as a promising approach to improve AI's reliability by understanding why it makes mistakes.
That's right.
We then explored how AI is being grounded in the laws of physics, using techniques like the mass-conserving perceptron
to create models that are not just intelligent, but also aligned with the principles that govern our world.
We also saw how reinforcement learning is being used to enhance AI's ability to detect anomalies, even when we have limited examples to learn from.
This has huge implications for fields like cybersecurity and fraud detection.
And let's not forget the exciting developments in large language models, from Guide LLM's ability to guide conversations and help with creative writing,
to ProverGen's quest to imbue LLMs with logical reasoning capabilities.
We also witnessed the power of foundation models like LLM, which is trained on the world's largest EEG data set to detect Alzheimer's disease early on.
And Decipher, which can predict the structure of crystals with remarkable accuracy.
We also discussed the importance of efficiency in AI, exploring techniques like SSH to compress massive language models without compromising performance.
And adaptively pre-trained encoders that allow AI to learn how to learn more efficiently.
And finally, we saw how AI is being infused with human-like perception, using techniques like knowledge-adapted captions
to ensure AI learns from high-quality data, and exploring ways to improve object detection in low-visibility conditions by mimicking human visual cues. That's quite a journey we've taken through the world of AI research. And there's still more to come.
You're right. There's still a whole section of papers we haven't even touched yet. Buckle up, because we're about to dive into even more cutting-edge research. Welcome back to the Deep Dive, ready to explore even more groundbreaking AI research.
Absolutely. There's so much exciting work happening. Let's dive right in.
What's next on our AI research adventure?
One fascinating paper explores the concept of using machine learning to enhance our understanding of complex systems, particularly in the field of hydrology. It's titled, Using Machine Learning to Discover Parsimonious and Physically Interpretable Representations of Catchment Scale Rainfall Runoff Dynamics.
Okay, break that down for me. How can machine learning help us understand something as complex as rainfall and runoff?
This research dives into using machine learning to discover simplified yet accurate representations of how rainfall transforms into runoff within a catchment area. It's about finding the essential elements that drive this process without getting lost in the overwhelming complexity of the system.
So it's like creating a streamlined model that captures the key dynamics of rainfall runoff. Why is that important?
Because these simplified representations provide valuable insights into the underlying processes, leading to more accurate predictions and better informed decisions about water resource management. Imagine being able to predict flood risks with greater accuracy or optimize water allocation strategies based on a deeper understanding of the system.
That's incredibly valuable.
Yeah.
How does this research approach creating these simplified representations?
They utilize a computational unit called the Mass Conserving Perceptron, or MCP. This unit is designed to mimic the fundamental laws of physics, particularly the conservation of mass and energy.
So they're building AI models that adhere to the same physical laws that govern the real world. That's a clever approach.
It is. By grounding AI models in the principles of physics, we can ensure that their predictions are not only accurate, but also consistent with the fundamental laws that govern the natural world.
That makes a lot of sense.
Yeah.
Now, shifting gears a bit, I noticed a paper that caught my eye titled Calibrated Unsupervised Anomaly Detection in Multivariate Time Series using Reinforcement Learning. The title alone sounds intriguing. What's this research all about?
This paper addresses the challenging task of anomaly detection in time series data. Imagine trying to identify unusual patterns in a stream of data when you don't have many examples of those anomalies to train your AI model on.
That sounds incredibly difficult. It's like trying to find a needle in a haystack when you don't even know what the needle looks like.
That's a great analogy, and that's where reinforcement learning comes in. This research proposes using RL to train an AI agent to effectively detect anomalies in time series data, even when we have limited examples of those anomalies.
So how does RL help the AI learn to spot these elusive anomalies?
In this approach, the AI agent interacts with the time series data and receives rewards for correctly identifying anomalies. It's like a game where the AI learns to distinguish between normal patterns and unusual events through trial and error, constantly improving its detection abilities.
So the AI is learning to be a detective, searching for clues and patterns that indicate something out of the ordinary is happening.
Exactly. And the beauty of RL is that it encourages the AI agent to explore different possibilities and learn from its mistakes. This helps prevent the AI from becoming too narrowly focused on the limited examples it's been exposed to, making it more robust and adaptable to new and unseen types of anomalies.
That's fascinating. Now let's switch gears again and delve into a paper that explores the cutting edge of large language models, or LLMs. It's titled Enhancing Pre-trained Decision Transformers with Prompt Tuning Bandits.
This paper highlights how researchers are constantly pushing the boundaries of LLMs and reinforcement learning. It introduces a novel technique that combines pre-trained decision transformers with prompt tuning and bandit algorithms to enhance the adaptability of these powerful models.
Okay, that's a lot of technical terms.
Yeah.
Can you break it down for us? What are decision transformers, prompt tuning, and bandit algorithms? And how do they all work together?
Decision transformers are a type of RL model that excel at learning from past experiences to make informed decisions. Imagine them as AI agents that can learn from their successes and failures to navigate complex situations.
So they're like AI agents with a memory of their past actions. How does prompt tuning fit into this?
Prompt tuning is a technique that allows us to adapt these pre-trained decision transformers to new tasks. By providing them with specific instructions or examples, it's like giving them a set of guidelines or a cheat sheet to help them quickly understand the new challenge they're facing.
So it's like providing the AI with a context-specific guide to help them navigate a new situation.
And what about bandit algorithms? How do they contribute to this process?
Bandit algorithms are a class of algorithms known for their ability to explore different options and identify the most rewarding one over time. They excel at making decisions under uncertainty, constantly testing and refining their strategies to maximize their rewards.
So they're like explorers, constantly searching for the best path forward.
Precisely. And by combining these three powerful concepts, researchers have created a system that allows pre-trained decision transformers to adapt to new tasks more effectively and efficiently.
That's impressive. It's like giving these AI models a toolbox of strategies to tackle new challenges and learn from their experiences.
Exactly. This research showcases the incredible ingenuity and creativity happening in the field of AI as researchers constantly strive to push the boundaries of what these models can achieve.
It's truly inspiring to witness this rapid pace of innovation. It seems like every day brings new breakthroughs and discoveries. It certainly does. And as we wrap up our deep dive into the latest AI research, it's important to remember that this is just a glimpse into the vast and ever-evolving world of artificial intelligence.
That's right. There's so much more to explore. And the future of AI holds incredible potential to transform our world in ways we can only imagine.
We encourage you to continue exploring the research papers that caught your interest. Delve deeper into the topics that sparked your curiosity. And stay tuned for more exciting developments in this rapidly advancing field.
That's a great note to end on. Thanks for joining us on this deep dive into the fascinating world of AI research. We'll be back soon with more cutting-edge discoveries and insights. Until then, keep exploring and keep learning.